Okay, gang, here we go. So, we are talking about how to name acids. Acids, remember, are compounds that have a hydrogen in the front of it. So, like, you know, H2SO4 is sulfuric acid. We've talked about hydrochloric acid a lot in class. So, all the acids are things that are going to have hydrogens in front of it. Okay, there's a different sort of naming convention for them that we need you to be familiar with moving forward. So here's a table that you need to be able to use, and I want you to memorize this. Okay? Now, it's not really as complicated as it looks. Let's walk through it. So, when you're naming acids, you need to look at the anion. So remember, this is the negatively charged ion of the two. Okay? So you're going to look at the anion, and then you have to figure out what the anion's name was. Okay? If the anion's name ends with an ide, I-D-E, like chloride here, then the way you name it is you say it's hydro, then you put the stem, and then you say ic. Okay, so ide gets hydro stem ic acid. So if you had HCl, right, so the anion is the chlorine, okay, and its name you know now is chloride, okay, so it's ide, so you're going to put hydro, and then the stem name, which is chlor, and then ic, and then we always write acid at the end, okay, alright. If the anion ends with ite, I-T-E, then you simply write down the stem, there's no hydro in front, and the ite turns into OUS, or us, acid. Okay, so this polyatomic right here is sulfite. Okay, this is on that list of things that I gave you. So this is sulfite. It ends in ITE. All you do is change the ITE to OUS, and you put that at the end. Now you might be wondering, well, why isn't it sulfus acid? And I don't really have a good answer for that. It's because this guy's sulfur. He's like the only exception to this rule. It's kind of an odd duck. But anyway, so like sulfuric acid, sulfurous acid, those guys all get weird treatments. They always get their UR back for whatever reason. Anyway, so this is sulfurous acid. We changed the ite to OUS and then added acid. And then finally, if it ends with 8, okay, so we've got nitrate here. All we do is we take the stem and we add IC. Now, I've got a cool way to remember this. You say you ate something icky. Yeah? So this is icky, right? You ate something icky. Anyway, so it turns into nitric acid. Alright, here we go. So, let's name some of these guys. So first you have to identify the anion. So in this guy, the anion is the NO3. So this is nitrate. So there you go, that's nitrate. And now you need to know. So now we're just going to take this name. So this is 8. According to our chart, we ate something icky. So this just becomes nitric acid. Pretty simple, right? You ate something icky, becomes nitric acid. Now this next guy, we're going to identify the anion, which is the fluoride here. So, fluoride. Alright. So this one I think is the hardest one to remember. So if it ends in ide, first you got to put the hydro. Okay? So you put hydro in first, and then you write the stem, which in this case is the fluor. F-L-U-R, O-U, whatever. And then we add ic, and then acid. Okay, so this guy ended in IDE, so it becomes hydrofluoric acid. Alright, now this guy, identify the anion, which is this SO3 guy. On your list, you know that that is sulfite. Okay, remember the ites turn to OUS's. Okay, so this just becomes sol. Remember this, since this is a sulfur, we get the UR back for whatever reason, and then OUS, so this is sulfurous acid. Yeah? And then this guy, identify the anion. It's this guy here, so you know that is sulfide. and because it ends in IDE, then you're going to add the hydro as the front, and then this is sulfuric acid. Cool, hydrosulfuric acid, H2S, which is different than sulfuric acid, which is the sulfate anion. Alright, here we go, phosphoric acid. So now you're going to walk backwards. So this is ick. Remember, there's no hydro on the front, so you know that it's some sort of polyatomic. Okay, so now we got to look for, if we're going to turn the phosphoric into its polyatomic, we know the ick turned into 8, right? So really we're just looking for phosphate. Okay, so we look for phosphate and your list, and you know that phosphate, I've got one pulled up that is a little bit funnier than normal, but anyway, so we got PO43 minus, okay, and we know since it's an acid, it's going to have hydrogens in the front. Well, hydrogens have a +1 charge. We know they need to add up to 0, so, or we could do crisscross, so we know this guy turns into H3PO4. So that's phosphoric acid. Alright, now we've got hydronitric acid. Well, first we need to see that it's got an ick, but it's also got the hydro, which means that it's elemental. Okay, meaning it's not a polyatomic. Alright, so we're just going to do, so we know the base, this is nitrogen, so we're going to put nitrogen, and it has a charge of 3 minus, right, when it's an ion. We're going to put H, right? I know that it's not polyatomic because I've got the hydro in front. Okay, so hydronitric acid, so now this guy's got a charge of +1. We can do crisscross, or we know that they have to add up to 0, so we know that we need H3N. Yeah, so that's hydronitric acid. And then nitrous acid, so nitrous acid is, got this, we know that this had to have come from an ite, right? Because ite turns to us. And so nitrous, so this means we got to find nitrite. We find it on our periodic table, and we see that it has a, or not periodic table, on a polyatomic ion chart, we see nitrite is NO2 minus, and because it's an acid, it's going to have an H in the front, which means it's going to turn into HNO2. And there's our nitrous acid. And that's it for practicing acids. That's all about that chart. Do some practice and then come take your checkpoint.